Hey, Ann Pierce. This is Dr. Jones checking in. This is the beginning of lecture test 2 material. This is endocrine. So this is AMP2 lecture test 2, video 1. So this is what your note set looks like. Test 2 says version 11, so hopefully this will be the most up-to-date version. Now, these first couple of pages are review pages, but I found when they were at the back of the note set, no one did them. So I'm putting them in the front so that y'all will remember them. And my door just randomly opened on its own. So there's page 2 and page 3. After we have finished this material, you should be able to fill all of this in. Now, pages 4, 5, and 6 are pages out of or from a picture in the book, and those we will cover together as part of the lecture. And my door just magically shut itself. So, dun dun dun. Well, it wasn't the dog. Okay, the dog is not bright enough to shut doors. She's cute. She's not real bright. I'm used to poodles. Poodles are such smart dogs. Okay, so this is the beginning of chapter 18 on page 7. You can see the 7 there, right? Yep, there we go. Page 7. Okay, so there is lots of material in the endocrine chapter. This is the only test that we will only cover one chapter, so that's how much material there is. Yeah, and if you have the mastering, the interactive physiology does have an endocrine section that is pretty cool. So there's that. Okay, so first let's do a review of endocrine versus exocrine. So we have, no, I didn't do it. Oh, okay. So embryologically speaking, we start with a single layer of epithelia, and that can turn into all the different types of epithelia. It can also grow down into the tissues to form a gland. Now, with an exocrine gland, and we studied these in 2401 with the integumentary system, with an exocrine gland, let's turn this to a pen so that I can make marks on things if I need to. On the exocrine gland, it maintains the duct. And just to be clear, every time I talk about ducts, I'm talking about tubes. So ducts. I am never in this class, except like right now, talking about waterfowl. Okay, so we're talking about ducks, not ducks. When you say it, the singular duct versus duck, you can hear the difference. But once you go plural, ducks and ducks sounds like ducks. And that's just it. So, but the duct is a tube, and we have lots of tubes in the body. So when they attach a gland to an epithelial surface, then that makes an exocrine gland. In an endocrine gland, the duct is lost, the connection disappears. And then the secretions, which for an endocrine gland, are going to be called hormones, will be released directly into the bloodstream. Now, in some tissues, they'll be released into the extracellular tissues, which then enter the bloodstream. So sometimes they'll say that hormones are released into the extracellular tissues, which are sometimes called interstitial tissues. And sometimes they'll say that they enter the bloodstream directly, and they all more or less mean the same thing. So don't let that one trip you up. It's all the same. Different words for the same thing. So there's your embryology for the day. Endocrine. All right. And there is nothing on this picture that you don't need to know. So let's cover these basic concepts of endocrine, and then we will dig into the note set. So the first bit here is the little snout of the seahorse in the brain, and it's part of the diencephalon, and that's the hypothalamus. The hypothalamus makes ADH, which I believe we already talked about. We said it was anti-diuretic hormone. And if you take a diuretic pill that makes you pee, anti-diuretic hormone makes you not pee. Okay. And oxytocin. Oxytocin is a cuddle hormone. So when you see like babies with those big eyes and like smell their little heads, you're like, oh, and you like melt a little bit inside. Oxytocin. It's a hormone. And regulatory hormones, and the regulatory hormones control the, I just covered the word, anterior lobe of the pituitary gland. And the anterior lobe of the pituitary gland releases the hormone ACTH, TSH, DH, PRL, FSH, LH, and MSH. Give me a couple of videos and you'll know what all of those mean. For now, know that the anterior lobe makes and secretes all of these hormones. The posterior lobe does not make any hormone, it only secretes hormones. And the hormones that it secretes are these two excretes? The hormones that it releases. It doesn't secrete them because it doesn't make them. So the hormones that it releases are the two made by the hypothalamus. So there's actually neurons that go from the hypothalamus down the infundibulum into the posterior lobe of the pituitary gland where it releases those two hormones. Okay. From different bits, but you understand. Okay, then the hypothalamic regulatory hormones. The hypothalamus is the boss of the endocrine system, and it tells the anterior lobe of the pituitary gland what to do. The anterior lobe of the pituitary gland is the manager of the endocrine system and tells many of these other glands, not all of them, many of these other glands what to do. Some of them are independent contractors. So the thyroid gland is controlled by the pituitary gland. The thyroid stimulating hormone, TSH, causes the thyroid gland to make thyroid hormones, which are T3 and T4. It also makes calcitonin, but not because the pituitary gland tells it to. We'll talk about that. The adrenal gland, oh, and the thyroid gland is right here. The adrenal glands make adrenaline and noradrenaline, which are now called epinephrine and norepinephrine. And this is the adrenal medulla, which is the squishy gooey filling, the center of the adrenal gland. And it makes these sympathetic hormones under direct neural control of the ANS, the autonomic nervous system. Sympathetic part, of course. The adrenal cortex, 2/3 of it, controlled by this one, which is the ACTH, which is adrenocorticotropic hormone. Adrenocortico, like the adrenal cortex. Get it? Okay. And then the pancreas is not controlled by the pituitary gland. The pancreas is right here, wrapped inside the beginning, the beginning of the small intestine wraps around it. Let's say that. And it makes insulin and glucagon. And insulin you've heard of. Insulin is released when your blood sugar is too high, and it causes blood sugar to go down. Excellent. And so glucagon will do the exact opposite. So when our blood sugar is high, we will release insulin, and it will make the blood sugar go down. When the blood sugar is too low, we will release glucagon. That's a G. What? I have doctor's handwriting. And the glucagon makes the blood sugar go back up. So these two work together for negative feedback. They're antagonists, but they work together. It happens. The pineal gland right here in the brain makes melatonin, and you take melatonin when you're trying to sleep. Melatonin helps you sleep. And the parathyroid glands are on the back of the thyroid, and they release parathyroid hormone. The parathyroid hormone and the calcitonin together do your calcium homeostasis. Again, antagonists that work against each other to maintain your hormone levels in your WNL, which I don't think we've talked about yet this semester. WNL means within normal limits. So it keeps the hormones within a normal range. The insulin and glucagon work together, negative feedback, to keep your blood sugar in a normal range. And the calcitonin and parathyroid hormones work together for calcium homeostasis to keep your blood calcium ion levels within a normal range. Very important. And so those aren't controlled. These pancreatic hormones and these two calcium homeostasis hormones are not controlled by the pituitary gland or the some of the independent contractors that we were talking about. Okay, the heart secretes the natriuretic peptides. Natrium is sodium, so that's why sodium is Na plus, because the Latin word for sodium is natrium. So these are important for sodium, which we will talk about when we get there. The thymus secrete thymosins, and this is important in immunity. M-M-U-N. I hate writing with a mouse. I-T-Y. That works. And then adipose tissue secretes the hormone leptin. Leptin helps with satiety, which helps you feel full after a meal when you're done eating. It tells you when you're done eating, although it doesn't work in everybody, which sucks. Coffee. Okay, so the digestive tract, okay, there's literally so much with the hormones and everything else in the digestive tract that we're not covering much of it because there's so much. And the kidneys, this part we are going to talk about the EPO, erythropoietin, and erythrocyte is the red blood cell. So erythropoietin, EPO, makes you make red blood cells. And then calcitriol will help with some of the other processes, specifically the renin, angiotensin, aldosterone system, but we'll get there. And the gonads, the testes make the male hormones. The male hormones are androgens, and the main androgen is testosterone. Ovaries make the female hormones, which are estrogens and progestins. And then both also make inhibin, which is important for inhibitory feedback control, which again we'll get to. Okay. All right, so that is this overview basic picture. I pulled up a timer and then forgot to put it on, didn't I? Yep. Not on. I was going to do 20-minute videos because the 30-minute videos are taking like 3 hours to load on YouTube, and it's a pain. Okay, but we will start this and do a page of the Noteset. So our bodies contain 30 chemical messengers known as hormones. We have hormones? Okay. And they regulate growth, development, reproduction. They also sleep, body temperature, hunger, stress management. Hormones are products of the endocrine system, which, along with the nervous system, controls and coordinates body processes. And then there are different types of hormones to relay information instruction to target cells, and we'll talk about target cells. There are different mechanisms of intercellular communication. Endocrine is only one. So let's talk about the others briefly, and then we will dig into endocrine for the rest of this note set. And mechanisms of intercellular communication. Endocrine regulates long-term processes like growth, development, and reproduction. Actually, that's everything I had on the previous slide. Use hormones to relay information and targets to the info to the target cells. Okay, now we are talking about target cells. Target cells are any cell that has a receptor for that hormone. So we talked about TSH. TSH is thyroid stimulating hormone. It causes the thyroid to both make and release the thyroid hormones. And so the target cells for TSH are only in the thyroid because only thyroid cells can make thyroid hormone. Thyroid hormone target cells are located all throughout the body. Oh, hey, it doesn't, oh, I moved me. I was going to say, it didn't mark on me. It marked under me. Ah, easily distracted. I apologize. Okay, so they, it looks like a toddler got a hold of my PowerPoint. It's like the meme that says, like the toddler version of what to expect when you're expecting a toddler or whatever it is, and like it's all marked over and like ripped, the corners are ripped off and pages are ripped out. And yeah, yeah. Oh, and my favorite toddler one is like a picture of a whole bunch of apples with one bite taken out of each apple. And that's what it's like to have a toddler. It's part of it. They grow out of it. It'll be a fun memory later, much later. So the TSH has target cells, but only in the thyroid. It causes the thyroid to make and release thyroid hormones. The thyroid hormones have target cells all over the body. Now, back to what we were talking about. Direct communication. The transmission is directly cell to cell through gap junctions. Here's a picture of a gap junction holding two cells together and also forming an ion channel. The gap junctions will be how the cardiocytes talk to each other. So these are relevant several times this semester. Well, right now and when we do heart cells. And the chemicals here are ions, solutes, and any lipid soluble thing that can diffuse through the cell membranes. And the adjacent cells, adjacent means next to touching, so adjacent cells. And they do have to be similar cells. And here's all of that in the chart. That didn't, okay, arrow button. All right, next are the paracrine communications. They go through the extracellular fluid. They are called paracrines, and they are local, and again, only to target cells, but local because they're not hitching a ride in the bloodstream and going all over the whole body. They're just going through the extracellular fluid to nearby, but they don't have to be touching cells. Autocrine, okay, this one is new and it still cracks me up. Autocrine hormones, or autocrines, go through the extracellular fluid and bind to receptors on the cell that released the autocrines. So you ever like text message yourself a note like the grocery list or like things you need to do or something you need to remember? Okay, this is what the autocrines do. They're messaging themselves. So back in the day, we used to like call our home phones and leave ourselves messages. If any of y'all are old enough to remember that. I don't think I ever did that though. I usually just write things down. I still think it's hilarious. And auto means self, like an automobile drives itself. It doesn't need a horse to drive it. Endocrine, and that's what we're here for this test. They're released into the bloodstream. The bloodstream, as you know, goes all the way through the body, almost everywhere. There's a few avascular tissues, but you get the point. And they're called hormones, and the target cells are all over the body. It depends on which hormone. And last but not least for this chart, we have, all right, where's the arrow? There we go. Synaptic communication. We talked about this at great length last semester for we talked about for test 4 and 5 and 6 a little bit. So across the synaptic clefts are called neurotransmitter, and it's limited to a very few target cells, literally only the postsynaptic cells. Okay. And our book makes a note of only a very small percentage of the body cells are innervated. Okay, so let's, bottom of the page, compare and contrast the endocrine and nervous systems. So compare means to show what two things, what about them are the same, and contrast means to show what things about them are different. So things that are the same, they both use chemicals that bind to receptors. They both use lots of the same chemicals. They both operate under negative feedback. So whatever's wrong, fix it. Whatever, too hot, make it cold. Too cold, make it hot. Blood calcium's too high, lower it. Blood calcium's too low, raise it. And they both work to preserve homeostasis. Homeostasis is the maintenance of a relatively stable internal environment, i.e. the bit that keeps you alive. So now let's talk about what's different. In neuro, the effects are short-lived. They only go to the postsynaptic cell. It's basically crisis management. So if there's a bus coming at you, it's your nervous system that gets you to jump out of the way. So crisis management. Neuro only goes to a small fraction of cells and uses neurotransmitters. Endocrine, unlike nervous system, does long-term changes like growth and development, like kids growing up, literally up and up. My son, as of this recording, comes to about here. So soon I will not be taller than him. Very soon. The endocrine goes to the whole body. All of the hormones hitch a ride in the bloodstream and go to the whole body and can affect target cells anywhere they are in the body. They don't have to be nearby or at the end of a synapse. And the chemicals are called hormones, not neurotransmitters. And this slide appears to be the slide for the beginning of the next page, but I'm trying to keep these to 20-minute videos so that I don't have to wait overnight for them to load. So we got through page 7. Okay. And the intro videos. So this has been a video lecture for ANP 2, lecture test 2, video 1. And we covered some introductory material along with page 7, which is the first page of the note set. All right. So thank you as always for tuning in. The education must go on. Dr. J out. And now I have to remember how to turn the video off. Command, Control, Escape. Command, Control, Escape. Have a good one, y'all.